our agenda for today is using the Azure Data Platform to predict employee turnover, a sample case. Feel free to connect with us on social media at Cloud Data Driven and follow us as well. I will share this with you. Today's presentations, as you know, will be delivered by Dr. Daniel. And then he is currently working as a senior cloud solution architect at Microsoft. Daniel will introduce himself and provide you more information about exactly himself. We do have a couple sessions lined up. You guys are free to go and save your spot. The next one is Azure Logic Apps for Azure Database DBA. And then we also have the Cloud Awakens Azure SQL Server for the on-premise DBA. Not only that, we have a tons of other sessions lined up. We are booked all the way to September, so you guys are free to go and register for anything that you feel like you are interested, that interests you. If you guys want to present a session, feel free to email it to me at jjoseph@bigdatadriven.org. Daniel, the floor is all yours now. By the way, it is an honor to have you here at Cloud Data Driven. Thank you for your presentations. Feel free to share your screen.
Great. Thank you so much for the introduction, and let's get started. So first off, can everybody see my screen? No? Take that as a no.
It is loading. I'm seeing your image. It might take a second to completely load.
Said somebody else has started to share. Let me try it again. Okay, how about now? Can everybody see my screen?
Yep.
Yes, I can see your screen.
Okay, great.
Thank you guys for your confirmations.
So my name is Daniel Dean, and I'm a senior cloud solution architect at Microsoft. I've been with Microsoft for about two and a half years now. Prior to that, I actually was in the small startup space, where I was part of a company doing unsupervised machine learning as a service. And before that, I was actually a research staff member at IBM based out of TJ Watson up in Westchester, New York. Basically, for those of you that haven't worked with a CSA or know what a cloud solution architect is, it's my job to work with different customers over solving data problems and doing it with Azure. Throughout my career, I've been involved with building cloud technologies, doing research in cloud technologies, building different cloud systems. So it's an area that I'm very passionate about, and I like building these kind of systems. So today, what I'm going to talk to you guys about is using the Azure Data Platform to predict employee turnover. And this is a sample case, so it's not like a real, I'm not using any kind of real data here, but this is actually based on a lot of things that I've seen and a lot of similar cases that others have seen in different areas. So it's not actual customer data, but this is typical of the type of workloads and type of machine learning and the type of scenarios that we're running into in the cloud. So the way that I want this talk, I've found this talk kind of works best, is I'm going to go through everything here, and we only have an hour. So I'm going to kind of go through and try to hit on as much of this as possible. But at the very end of this, if we don't have enough time to talk about next steps, I'm happy to talk with anybody offline if they want to connect with me about anything that we don't cover today. Also, if anybody has any questions, I'm going to pause at certain points and ask for any kind of, people have questions. Please don't be afraid to ask. There's definitely when this has worked the best has been when it's kind of like a dialogue almost, when we're having like a chat. And I can go in and answer your guys' questions, or if it's something that I don't know how to answer, I can certainly follow up and get you an answer, and we can correspond offline. So with that being said, what I'm going to do, the outline of what we're going to talk about today is, first I'm going to go over the scenario that's going to run like that's going to basically be the premise of this whole talk, what we're trying to solve. Then I'm going to go over the Azure Data Platform to talk about the different components, some of the stuff that we see, and how it all works together to solve this problem. From there, I'm going to go into specific parts of it. So because this is an example and I wanted to show some actual code, we're not going to go over the whole end-to-end productionalization of this. There's going to be mainly, we're going to look at the ingestion, storage, and machine learning parts of this. So I'm going to do a deeper dive into each of those components, talking about how they're used and some additional kind of details. Then we're going to go over some architecture patterns that the Azure Data Platform are kind of commonly used to solve these kind of data problems. Then we'll go into actual code, show what this looks like in the Data Factory portal and in Azure Databricks itself. Then if we have time, we'll do next steps, talk about how we can take this stuff and productionalize it, and wrap up with any final questions. So the scenario that we're going to try to tackle here is, we have a sportswear company. This company is having trouble controlling their employee turnover rates, and when somebody leaves a company, it's really expensive. It can cost up to 300% of their annual salary. What they wanted to do is they want to look at, well, can we solve this? Is there anything we can do about this? Can we use machine learning? Can we try to build some kind of a model in order to identify build some kind of a model to identify if an employee is likely to leave the company or not. So that's the kind of end scenario. We have some data that they provided for us. We're going to take a first stab at solving this problem, and we want to make sure that this isn't biased towards any one area, and this model, based on the data that we have, is going to accurately, as accurately as we can get it, is going to predict if an employee is going to stay or is going to leave. So this is at a high level the problem that we're going to be solving, and we'll go over how we're going to use the data platform to solve this problem. So now, to switch over to the Azure Data Platform, how can we use Azure to solve this scenario where we want to build a model to predict employee turnover? Couple of things to note up front. There's really, I'm going to talk about a bunch of different things. There's really, excuse me, there's really no right or wrong solutions. There's only optimal solutions. If you can make it work, great. There's sometimes better ways to do things, but there's a lot of different ways to do this kind of stuff. So this is my approach to it. This isn't necessarily the only approach that would work in solving this kind of a problem. The services I'm going to talk about are things that I know have worked well with different customers I've worked with, and I know that they're going to be able to solve this problem. That's not to say it's the only way. Lots of different ways to do this. And then there's lots of new services that are kind of coming online every day. So there's all kinds of ways to tackle these problems. I'm not taking price into consideration. I'm kind of taking performance into consideration, but price and performance, it's always a trade-off, and there's a lot of different things to take into consideration. Skills as well. If you're a Python shop or a SQL shop or .NET, there's all kinds of different considerations to take into play here. And being as we're all in tech, everything is fluid. This works today. Tomorrow, there might be the hot new way to do things, and this might totally not make sense anymore. that's the world that we live in, for better or for worse. So this is just the way that I chose to solve this problem. And if you have your own ways, you want to talk to me about that, I'd be happy to discuss with everybody offline. So broadly, when we're solving this kind of a problem, there's a couple of like broad big data analytics solution scenarios that it's kind of like an evolution, starting at one and moving through as you get more mature. The first one is modern data warehousing. So before we can even look at doing analytics and building models and all that, we have to basically make sure that we can get our data into the cloud and basically get everything we need there, all the infrastructure, the tools, the services, to be able to host that data in the cloud, to start to look at doing more advanced things on top of that. So the first step is modern data warehousing, getting everything in, kind of getting stuff into unified data lakes so you don't have silos. That's kind of the first step here. The second one is more advanced analytics. Now that we have everything in, how do we build some models on top of this? So instead of just doing dashboarding or reactive things, we can start predicting things ahead of time, right? And start building models that can run classifications over huge data sets. That's the second area. And then the third one is real-time analytics. So if you have data coming in and you want like to the minute responses, or you like to the second, you want to see what's happening in dashboards or feed that into your models, that's real-time analytics, and that's usually not the cheapest to do. But if you have that kind of use case, it's certainly something that we can tackle. What we're going to be looking at to solve this employee turnover problem is really the advanced analytics portion. That's what we're going to be kind of at. We're going to assume that the data is in the cloud, but we can talk through how we'll get it in, or the stuff's in place, and we're not making a decision over do we want to use Data Factory or things like that. This is we're going to focus on really the advanced analytics portion. So diving into that in a little bit more detail. Advanced analytics, when we're building models, we're doing machine learning, there's typically a couple of different phases around this. The first thing is you got to get the data and you have to understand what it is you're looking at, right? From there, you have to basically go build some kind of a model, do whatever machine learning you're going to do, and you need to make sure that that works, right? Not just on your small data set, but you also have to make sure that it works on a larger data set. So when you deploy this thing into production, it's not going to completely crap out on you, and you're going to get the same results you expect. And then lastly, we have the productionalization, which is you want to deploy this model, you want to package it up, you want to take that model and integrate it into your different products and services so that you can get value out of that model. There's different teams typically that work around these different areas, but there's also in the overlap, if in these in between, there's kind of like that's where there's gray lines, where like in this area, you have data scientists largely are the ones that are doing the, or I'm sorry, data engineers are largely the ones that are getting the data in and then kind of doing the cleanup, doing the joins, transforming the data and handing it off to the data scientists. So the data scientists are somewhere around here where they're going to be kind of picking it up. They're going to be the ones that are going to do all the modeling, get everything ready, build their cool machine learning models, and then package up those models. Now, the way that they package them up, and when they, the way that we take those packaged models and deploy them to a production environment, that's going to be, again, probably a different group of like DevOps engineers that are going to pick this up, and they're going to take those models and integrate them into different ML ops, which is DevOps for machine learning, different ML ops processes to get that production value out of those models that the data scientists created. So it's kind of it's not like when you're working on this, we're going to see the gambit. We're going to go through the whole, like, how does this work from doing some simple transformation to basically the machine learning. But in practice, you're going to have different groups that are working on these different pieces to really get production value out of these models. Before I move on here, are there any questions from anybody? Is this does this make sense?
If you guys have any questions, feel free to unmute yourself or raise your hand.
All right.
Just give them a couple seconds. Sometimes there's a delay, probably 15 to 22 seconds.
Sure. All right. So
Okay.
moving on. So this slide is basically a snapshot. This is a slide that I use all the time when I'm talking to different customers, from early conversations to scoping out POCs. I really like this slide, and it kind of captures parts of the Azure data platform that are commonly used to solve these kind of big data problems. From modern data warehousing to even to advanced analytics, and even parts of this for real-time analytics. So what this slide, this is not a entire, if you go into the Azure portal, there's a ton of different services here. This is by no means an exhaustive list. These are just some of the commonly used services that are used or that I've personally worked with different customers to solve different kinds of problems. So on the left-hand side, we have all of our data. That data can be structured, it can be relational, it can be unstructured like images, audio, semi-structured files, like maybe you have something like JSON, right? But all of your data sits here, and it's in the modern kind of data estate. All of that is usually heterogeneous sources, meaning that you have some data sitting in Oracle, you got some stuff sitting in an S3 bucket, you have some stuff sitting over in a file system somewhere. So the first thing we need to do is we got to take all of this data and we need to basically ingest it into Azure. And the service to do that that I like to use is called Azure Data Factory. Azure Data Factory is a scalable data orchestration and ingestion service that has lots and lots of connectors, lots and lots of ways to move data, pick up data, and move it around and orchestrate different pipelines. I'm going to talk about this in detail, so I'm going to skim over that for now, or that's all I'm going to say about it for now, but it's a great service for picking up data, getting it into Azure, and then orchestrating end-to-end data pipelines. Once we have that data moved into Azure, we need to land it somewhere, right? Moving it in, we got to put it down. We've picked it up, we got to put it down somewhere. And that's the next area, which is long-term storage. So starting on the left here, some of the most common ones that I've seen, Azure Data Lake Store and Azure Storage. Talking about those two together because they're kind of the same thing. Azure Storage, I'm talking mainly about blob storage. It's, at the end of the day, it's cheap object store. The only difference between the two are, do you want a file system on top of it, or do you not care? If you're uploading a bunch of PDFs, just landing them in a container to go do something with them, then Azure Blob Storage is going to be a great choice for that. If you need, you're using Spark, big data processing, or you have fine-grained security controls such that only one group can see one directory and another group can see another directory, then Azure Data Lake Store Gen 2 is what you're going to want to use for that. So, but at the end of the day, it's cheap object storage. It's great for big data processing. And it's really, really good for data lake centric implementations. Moving on, we also have Azure Cosmos DB. Azure Cosmos DB is NoSQL. It's the native NoSQL Azure offering, where basically it's a distributed database. If you have a bunch of JSON documents that you need to store and you can distribute those over a bunch of different nodes, or you have an application that you need a globally distributed, like you have a globally distributed application and you want a unified view of that. So you want to know all the time without having to worry about table replication and all that stuff. You want to have a view of what the system looks like at any time. Great choice for that. It supports a bunch of different APIs, and the switchover, like if you have a Mongo application and you want to use Cosmos, the switchover is as easy as just picking up the connection string, switching out the connection string to Cosmos, and the API support is there. So you don't have to go rewrite your whole application. So Cosmos is pretty cool for NoSQL use. And then we have relational. So I have SQL DB listed here. Not the only one. We have IaaS versions where you can have SQL running on a VM. We have managed SQL DB on Azure, which is you get a managed SQL server that you can put your own databases on. SQL managed instance, which is I just want a database and I want to be able to, you handle everything else. I just want to put stuff in, pull stuff out. Besides that, we also have Postgres. We have managed Postgres. We have MySQL. We have MariaDB. All kinds of different flavors of relational databases depending on what you want to use. But each of these, so for long-term storage, depending on the use case, there's a bunch of different options. So now to come back to the problem that we're trying to solve, the one that we're going to use here, we're going to use Azure Data Lake Store Gen 2 because we have flat CSV files. That's where the data is stored, and we're using Spark to process this. So Data Factory is going to be our orchestration engine. We're going to use Data Lake Storage to secure or basically to store that data and process it at scale. And then we're going to use Spark to process that. And that brings me to kind of my next area here, which is going to be data processing. So in terms of data processing, we have a couple of different options. I'm mainly talking about ETL here. So like data cleaning, kind of table joins, data mastering, stuff like that. The first one is Azure Databricks. So Azure Databricks is scalable Spark as a service. It's a really great service that I'm going to talk about in detail. So I'm not going to spend too much time on it here, but you can stand up clusters, run a bunch of Spark jobs, have those clusters come down. And when I say write Spark jobs, the library support for this, the library support for Spark has really, really grown over the past couple of years. So you're not writing MapReduce code. You're really using a bunch of different libraries, making some API calls, and it all gets translated under the hood to Spark jobs that get run on a cluster at scale. Moving on to Azure Functions. Azure Functions is Microsoft's serverless offering. It's a block of code as a service. You're basically writing it in your favorite IDE. It packages, you package that code up and deploy it up to Azure, usually in like a lightweight container. And that code scales out horizontally to do whatever you want it to do. If you're calling a REST API, right? And you want to go kind of munge the data a little bit when it comes back, and you're not doing too much heavyweight work, Azure Functions is a great fit. It's also really good for stream processing systems where I got Kafka, right? And I have a bunch of different messages coming in on Kafka. I can connect a function to that, and as those messages come in across a bunch of different topics, I can scale this thing out horizontally and quickly grab those messages and pass them on to be processed by whatever your processing engine is, or to store them, which is probably a better idea anyways. Pick them up off Kafka, store them long-term, then go process them. Really good for that kind of stuff. And it also, depending on the languages, I've done some heavy-ish weight ETL with like, if you wanted to do your ETL in .NET, if you're exclusively a .NET shop. Azure Functions, we support .NET, Java, Python, a bunch of different languages. So depending on what the requirements are, you can use it for ETL. And then lastly, we have Hdinsight for data transformation. And Hdinsight is really, it's the rest of the Hadoop stack. Databricks is Spark. That's all they do. They do it very well. Hadoop, if you want HBase, you want native Hadoop, then Hdinsight is the way to go. So for data processing, a couple of different options here. Moving down to data enhancement. So we have the Azure Cognitive Services. And what I'm talking about for data enhancement is mainly taking unstructured data and adding human understanding to that. So doing OCR, optical character recognition, doing natural language processing, doing speech to text, text to speech, that kind of stuff. We have a whole host of services where we can quickly take that unstructured data and extract meaningful information out of that, which you can then use to build more accurate machine learning models, or even just to store it and know that, hey, here's a doctor's note, right? And then I did some NLP on it, and now I know all the diagnoses that are coming out of this big data set where I have all these doctor's notes, and now I have diagnoses that go into a dashboard so somebody can take a look and say, wow, there's an uptick in cancer, right, or asthma based on that. So a lot of cool stuff you can do there. I could probably spend 2 hours talking about that by itself. So if there's any questions, we can take that offline, kind of around any of these. I'm happy to talk in detail, but in the interest of time, I'm going to kind of keep going over some of these. Unless it sounds like there is a question. Somebody came off mute. Okay, so moving on. What I basically, so to come up here, to go back to the problem that we're solving, we have, we're trying to build a machine learning model in order to predict employee turnover. We're going to store it in ADLS. We're going to process it with Spark and do our transformation with Spark. And then we're going to come up and we're actually going to build the model with Spark as well. But that's not the only way that we can do machine learning in Azure. Starting simply, we have the data science VM. If you want a Jupyter notebook with a bunch of pre-installed libraries, TensorFlow, Keras, PyTorch, things like that, the data science VM is a great, it's basically a VM image. It's great for small data science teams where they want to just have a Jupyter notebook and just start to do some data science without having to go manually install everything themselves. Moving on, SQL Server. So recently, we've added machine learning capabilities where you can actually execute directly on SQL Server using T-SQL. You can run Python and R scripts that can do things, simple things like a linear regression, stuff like that, directly on the SQL database engine itself without having to move the data around. So that's pretty cool. If you have some simple machine learning use cases, you can run it directly there on SQL Server. Azure Databricks, we're going to see in detail, so I'll skip over that. Huge data science community. These two, I do want to touch on a little bit. There's the Azure Machine Learning Studio, which is kind of deprecated, not being supported as much anymore because it's been rolled into the Azure Machine Learning Service. So the Azure Machine Learning Service is basically two parts. The ML Studio component is there's like a designer. It's a drag and drop area where you can do data science by dragging different components on, saying, hey, here's the data, go do some clustering and drag and drop. I don't want to write code, but I want to do data science. It also, the Azure Machine Learning Service itself is a Python SDK that you can import into your favorite Python area, be it Jupyter Notebook, be it Azure Databricks, and then you can use that to do all kinds of things like algorithm selection, automated parameter tuning, or even model deployment. You can take the model that you've created, package it up, and then push it out to get production value out of that model as part of a DevOps process. So a bunch of ways to do machine learning in Azure. For our problem, we're going to focus on Databricks. And then coming down here for trained model hosting, once we have our model packaged up, we have to store it somewhere, right? Bunch of different options. Depending on how there's no one machine learning model. So there's a bunch of ways to store machine learning models. Azure Machine Learning has, you can containerize a model and basically put it into a registry. That's built into Azure Machine Learning. Cosmos DB, believe it or not, when I was at a startup, we represented our not deep neural network. We had an artificial neural network, and we actually represented it as a CSV. So for something like that, we access it through a bunch of searches that we used with Cassandra. We would maybe store something like that in Cosmos DB. And then lastly, Azure Kubernetes, right? If you have your containerized model, you can run that against Azure Kubernetes and keep like your containerized model there. The last part, serving storage. So talking about this a little bit, the serving layer, the idea is that we're landing the data, transforming it, maybe doing some modeling, getting all that ready, and then we want to serve that to our downstream applications, our downstream dashboards. It's usually a good idea to keep this separate from this because you're running different kinds of workloads. These are usually write heavy, whereas these, and then a mix of reads with new data and stuff to do your ETL. This is typically very read heavy as your applications are pulling from that. So you're going to have different data distributions, different tables, different sizes. So having the serving layer usually makes sense here. And a bunch of different options. Synapse Analytics, formerly SQL Data Warehouse. If you have lots of data, we can handle that and serve it very quickly. If you have not as much data, we can handle that. If you have no SQL, globally distributed views, we can certainly handle that as well. Bunch of different options for serving storage. What we're going to see today, we're going to focus on the model training and the ingestion, building the model. We're not really going to focus on this, but as part of the picture, we'll see what we could use for serving storage. Before I move on, are there any questions about this? Any of the services I talked about? All right.
I think there is none.
moving on. Now what I'm going to do is talk in a little bit more detail about the different components, Data Factory, Azure Data Lake Store, and Spark. And then from there, we'll go to a demo of this, and we'll wrap everything up. So Azure Data Factory, this is kind of like a high-level view. It's a great tool for hybrid data ingestion at scale. It uses a drag and drop UI to build data pipelines. You don't have to write code, but you certainly can if you wanted to. It allows you to move data from a variety of different sources. You can actually run SSIS packages on the data or on Data Factory itself. It's scalable and it's totally managed, so it's not like you have a bunch of VMs to maintain. The service itself is totally handled, and you're just kind of building these data pipelines and controlling access to those pipelines. And then it's certified, so if you need to move PHI, it can certainly do that. And there's a bunch of data attestation that we've done around Data Factory to make sure that it's moving data securely from point A to point B and orchestrating your data pipelines in a trusted, secure way. Azure Data Lake Store Gen 2, that's going to be our storage solution we're going to use here. It's secure, lots of security. You can add security at the directory level, protect different files, protect different folders. Everything's managed through Azure Active Directory. There's different tiering that you can apply to this. It's super fast and scalable. It's built on top of object store, so that means that it's really cost effective and it's great for data lake centric architectures. And it integrates, there's a bunch of different ways you can integrate with this, from the REST API to different SDKs to native connectors, such as the one in Data Factory. So Azure Data Lake Store Gen 2 is a great data lake kind of great storage solution. If you have a lot of data you want to store and you want a file system on top of it, it's a really, really good solution for storing that kind of data at scale. So now for our problem, because we're using Spark to solve this, we're using ADLS Gen 2, but kind of as a secondary, almost as important, I would say probably as important thing is we're doing this for a company, and the type of modeling they're doing, there could potentially be a lot of data here. So in doing that, I wanted to make sure we have a scalable solution for this. So that's why we're using ADLS Gen 2 as part of this solution. Now, this I wanted to touch on briefly. If you guys go into the portal, when you go to stand up ADLS, it's actually through the Azure Storage. That's where you get to it, through the Azure Storage service. The reason for that, and the reason that they're not two separate services, is they're built on the same backbone. And ultimately, these two APIs are going to come together, and it's going to be the same functionality supported among both of them. It's just, do you want a file system or do you not want a file system? So that's where we're going to, and I think this picture kind of illustrates that. But at the end of the day, we're not there yet. There's still some kind of things between each of them that like Blob Storage has an archive tier, for example, whereas ADLS doesn't. And there's different triggering. There's different capabilities supported in each. But this is where we're going for this unified storage API. So then the last component is Azure Databricks. So Azure Databricks is a separate company. Azure Databricks is a first-party service at Microsoft. It basically, Databricks is the creators of Spark got together and made a company. It's really, really a great implementation of Spark. They built it, or they invented it, so they know how to tune it. So it's really, really fast, and it's a super intuitive like workspace, and it works really, really well when you have collaborative teams that need to get together and kind of collaborate on data transformation or doing data science at scale, where you have a bunch of people working on different parts of things. It works really, really well for that. And it's natively integrated into Azure Active Directory, all kinds of like the Data Factory connector. There's a really good connector that we're going to see that'll allow us to actually go see what happens when we have a successful job complete. We can just integrate it, click on a link, and it'll take us right there. And it's secure. So it's kind of taking the best parts of Databricks, the best stuff of Microsoft, and combining those together to give us Azure Databricks. You create this through the portal like you would with anything else. Since it's all a first-party service, that means you're not going to Databricks externally. You do everything through the Microsoft portal, manage everything there. The integration with the storage services is great, and the integration with Active Directory. You're not maintaining separate lists. You're basically logging in. It's passing through your credentials, and you're good to go. And all of the billing and all of that stuff, that's all managed for you. So you don't need a separate account. The takeaway of this, scalable Spark as a service. It's integrated tightly with Azure where you're not maintaining, different things with a different company, and it works incredibly well with Azure services. All right. So now moving on, I want to go through quickly a couple of architecture patterns that we commonly see for solving the type of problem that we're looking at here, which is predicting employee turnover. So the first one we talked about was the modern data warehouse pattern, where we have our data sitting on the left here. We have Azure Data Factory to ingest the data, gets landed in ADLS, gets transformed with Spark, and then served to SQL dedicated pools. If we need analysis services for a semantic model, we could apply it there, and then visualized with some kind of a downstream, like a dashboard system, something like Power BI. I've implemented this pattern at a bunch of big pharma customers I work with. It works incredibly well because it scales horizontally and it leverages cloud services. You pay as you go, so you're not running things 24/7 for the most part. Really fast, really performant, and pretty cost effective in my opinion. For handling, as opposed to just dropping everything into a SQL server or into like Redshift or SQL dedicated pools and doing everything there. Because you're leveraging horizontal like Spark to scale horizontally and ADLS Gen 2 as cheap object store, you end up doing things faster and cheaper compared to other approaches. And it opens you up to doing advanced analytics on Azure. This is similar, and this is blob storage here, but keeping in mind what I was saying before, it could be blob, it could be ADLS Gen 2. For this case, it could be either. What we're going to do is ingest with Data Factory, land it in Azure Storage, build our machine learning models and do our transformation work with Databricks, and then serve those models and take the results of that, serve them in batch, serve them in near push them out with different connectors to some of our downstream consumers, be it Cosmos DB or our dashboards for different downstream consumption. And then the last one, near real-time analytics. This is more for, it's similar to a Lambda architecture. The bottom part looks almost the same as before, like this part, but what we did was we added a hot path. So I have Azure Kafka on Hdinsight. Doesn't need to be that. There's event hubs. We have a bunch of queuing solutions. The idea is that you have your streaming data coming in, going into this queuing solution, being processed with structured streaming, and then pushed out to wherever you need to handle it. So these three patterns I've seen very frequently in the different folks that I've worked with, and this kind of stuff, you can plug and play kind of different pieces of this puzzle, but broadly these patterns work well for processing large amounts of data at scale. So now to kind of bring this back, we went over a lot. That's the Azure Data Platform in 30 some odd minutes, however long I've been talking. There's a lot there. What were we talking about again? We're working with a sportswear company where we're trying to predict employee turnover based on this employee left column that they have in some data set. And we don't want our model to be biased. So to go back, this is the problem we're trying to solve. Let's see what a concrete implementation using all of those pieces and all those broad patterns and stuff, what does that actually look like? And here's an example architecture of what this on Azure would look like to tackle that problem. Our data is sitting here. It could be in a variety of different sources. For our example, it's just a flat file coming in. We're going to land it in Azure Data Lake Store Gen 2. We're going to use Databricks to process it. The whole thing's going to be orchestrated with Data Factory. Once we do our processing, we're going to save that model back to ADLS Gen 2, where we can have a different process, go productionalize it, deploy it to Azure Machine Learning Service, where then that way we have Azure functions, our applications come in, they call different APIs on functions, those do some translation and call the model here. If the users have batch predictions they want to do for dashboarding, they can come in and run those models directly on Databricks. And doing this, we can handle batch and we can handle applications that want to call different APIs in order to predict employee turnover. Now, the batch case could be quarterly, right? We have a company and they want to know at the end of the quarter, what are the employees that are likely to leave? Let's create a dashboard where we could see that. Application cases could be an employee gets brought in, right? They're up for a promotion. Let's pull up the person's record and let's take a look and see, well, are they likely to leave? Like, it could be used as part of their evaluation. How are they doing? What does the model think in terms of them being likely to leave? So in that case, when the application pulls up their record, we could make an API call to basically see how do they look? Maybe they're not happy with things. Maybe we should increase their salary or take some action to make them happier so that we keep them around. So there's different use cases, and this kind of an architecture would be able to handle both of those use cases. So now what I'm going to do is show what this architecture looks like in actual, instead of just looking at slides here, let's look at some actual code. So this is Azure Data Factory. In the interest of time, I'm not going to go through all of this, but basically what we have here is we have different, let's pop this open. Yeah. We have a landing area where we can create different pipelines. And those pipelines are comprised of different activities that we can do different things on. So in this case, what we're going to do is we're going to take that CSV data, that employee data that we have, right, that we're going to build the model. We're going to copy it from our landing area to long-term storage. And then we're also going to copy it to staging, where we're going to do some simple ETL, convert it from a CSV to a more native big data format. And then we're going to take it and we're going to build a model on top of that. Once that model's done, we're going to save that model back to ADLS, and then we're going to be done with our machine learning part. So out of the box, you get a lot of different capabilities. The connectors, just to show this quickly, there's a ton of different connectors. In a previous life, I had to write connectors as part of my job. I didn't want to be doing that. I wanted to work on more interesting, like even the data cleanup or the working on some of the like data science aspects. That's what I wanted to be doing. I didn't want to work on the writing a connector, figuring out somebody else's API. Using these built-in connectors, you don't have to do that. If you want to pull in from, let's say, Teradata, I can go over here, use the Teradata connector as part of my pipeline to connect to Teradata, and then the API is implemented for me. So I can just say, hey, grab the table, grab the data from this table, pull it over, and land it over here. Really can't say enough good things about these. Data Factory works really well from on-prem sources as well without having to punch holes in your firewall using a push model. So it can securely pull data from on-prem locations, get it into the cloud where you can start doing some heavier weight stuff on it. On top of that, it also has built-in monitoring. So if I come to this, we're going to see a whole bunch of pipeline runs. What I'm going to click into here is this is a successful execution of a pipeline run that I executed around this case. So coming back to this slide, this is basically what the implementation, what the orchestration looks like to implement this architecture. So now coming back here, we can see there's a bunch of details I can get. Like if I come over to here, we can see I pulled in, this is like a pretty print version. I pulled in 962 kilobytes, one file, and I wrote that out. Peak throughput was 30 kilobytes a second. That's not much, but this scales horizontally based on size. So personally, I've seen 130 megabytes a second, and I've been able to copy 10, 20 gigabytes in a few minutes from on-prem to Azure using this service. So there's also some of the tight integrations I was talking about with Databricks. Databricks is tightly integrated with Azure Data Factory. So coming over here, if I come over to Parquet, I can take a look at this, see the duration, how long it took. Most of that was probably to stand up the cluster. So what I can do is click into this and take a look and see what's actually happening here. So while this is running, all of these, some additional details, all of this stuff can be parameterized as well. So like as an example, if I pop back over here, this notebook is parameterized. I'm pointing it to an Azure Databricks instance, and then this whole thing is parameterized, right? So I'm passing in the file name and a file system to use as parameters to this Databricks notebook that is basically a Spark job. And what's going to happen is it's going to run that Spark job on the cluster and do whatever I have set up in this notebook. So coming over here, we can see I'm passing in some file name and file system. When I look at the successful execution, I can see these parameters were passed through. So the raw data CSV and the file system we're going to use is staging. And then I can also see how long each element, each cell ran here. This is the Databricks workspace. If anybody's familiar with Jupyter Notebooks, it's very similar to that, where you have cells and you run those cells against a Spark cluster. So this thing ran in 0.1 seconds. Databricks itself, one thing I forgot to mention, supports 4 languages: Scala, SQL, Python, and R, and you can use those interchangeably. So what I have here is, since the data lives in Azure Data Lake Storage Gen 2, I'm adding the credentials so that the Spark cluster can talk to ADLS Gen 2. Then I have a little helper function to do some simple ETL using Spark. As you can see, I'm not writing MapReduce code. I'm made a couple of API calls, and I'm doing that in a function. And then coming down here, I'm reading in the CSV. And then what I'm doing is I'm passing that, I'm reading that into a data frame, and I'm doing some simple transformation to replace these blanks, these spaces, with underscores. So I can save this whole thing as Parquet, which is a more native big data processing format. Coming down here, that's what's happening. I'm writing it in, appending to it, and I'm calling it training data.parquet. So now coming over to the data science side of things. If I come over to this, sorry, not over here. If I come over to this, then over here, and I come to batch train model. So now what we're going to do, same thing, parameterized with some stuff. What I'm going to do is pull out those parameters, talk to ADLS, make sure the credentials are there. Then I'm going to start doing some data science. So I'm not going to go into too much detail about the data science that we're doing here, but if anybody has any questions, I'm happy to talk about this in detail. I just kind of wanted to keep it broad, depending on the level of depth that everybody has here around data science. So the first thing we're doing is we're loading in the raw data that we saved in our previous step. So we're loading our Parquet, doing spark.read.parquet. Then what we're doing is we're going to cache it in memory for faster development. I want to look at some stats, see what the mean, standard deviation, make sure the data looks okay and there's no real obvious things that are standing out. That's something I need to look for. This is a helper function to get rid of the data labels in building the model. So because the APIs are going to be expecting the labeling to be in one area and then the data itself to be separate. Then looking at the data itself, I didn't want to keep the university because I don't want any kind of bias. And current model likelihood or current model evaluation of likelihood to leave, I don't want that because that seems like cheating. If I'm building a machine learning model to predict if an employee is going to leave, then I don't want to know if the employee, like any kind of model already says the employee is going to leave, right? Because we're building something to replace that. So I'm removing that because it seems like cheating to me. So then coming in here, once we have our data ready to go, and we've done our simple kind of like feature selection, then what I'm going to do is split this into training and testing data. It's pretty typical. You train the model on your you take your data set, split it into training, testing, usually 70, 30, 80, 20, something like that. And what you do is you train the model on the training data and you test it on the testing data. So that's what we're doing here is we're splitting it into training and testing data. Then I'm using the chi-square test in order to identify what features are related to each other. This kind of works. It's kind of similar in a way to for feature. It's useful for feature selection in the sense that it works kind of like PCA, where you can identify the interesting predictor features and kind of get rid of the features that are independent, that really don't have any kind of correspondence to any kind of like they're useless. They're just noise. So using this test, we can identify some features there. I also use a gradient boosted decision tree for feature importance. So what we can do is we can build a decision tree, see how that looks, and then basically look at what features were. A decision tree is just a big tree with a bunch of different branches, left or right, depending on the condition. And a gradient boosted decision tree, it's going to build this whole thing for me, and it's going to use some machine learning to basically to construct that tree uh, in such a way that I don't have to manually create this whole thing, right? So what I'm using this for is feature selection, or I'm sorry, feature importance here, where what I can do is I can look at what are the weights, right? So how much does each feature, what are the important features, what are the not so important features in getting to a prediction down this decision tree. So basically what these two, the TLDR there, is I'm doing feature selection. I want to find, I'm using two different approaches because I want to look at what does the chi-square test say, what does the gradient boosted decision tree say, like are my important features, because I don't really know anything about this data here. And I'm going to take the overlap of those two as those are really the important features that I want to use in my machine learning model. So that's what I'm doing here, is I'm getting the overlap, selecting those overlapping features, splitting that new data set into training and testing, same thing, 80-20. And then I'm going to build a logistic regression model, and I'm going to use some auto parameter tuning. Every machine learning model ever has different knobs you got to tweak. Those knobs depend on the type of machine learning model it is. In this case, I'm looking at the regression parameter and the number of iterations. Clustering, if you have like k-means clustering, you can look at the what's the k that you're targeting. If you're looking at like hierarchical top-down clustering, you might want to look at what's the threshold in order to split your clusters. Like how far apart do points need to be before you split them apart from bottom up? How close do points need to be before you group them together? So either way, you can there's different parameters you need to tune for any machine learning model. And traditionally, what I did in grad school and in previous jobs is I would put things into like a for loop, let it run overnight, come back, and there's my parameters, right? That seemed to work well. Or I'd leverage like, oh, I know this works for this kind of a model, so this is where I'm going to start. We now, thanks to AutoML, we have ways to do that automatically using like parallel processing in the cloud. And that's what I'm doing here, is I'm using AutoML to automatically try out a bunch of different configurations, make sure I have the best model possible, the best configuration of that model possible. All my knobs are tuned appropriately. And I know when I run this thing, it's going to be the best configuration I can get for that type of a model. So if it doesn't work well, then I know that it's not really a knob I'm not tuning. It's something fundamentally where I have to try a different algorithm to solve this problem. Cross-validation is a way to make sure, so you take your training data, split it up into equal parts, make sure you're getting a good configuration. It's how you do this, this parameter tuning. You use something called k-fold cross-validation. And then from there, I'm building my logistic regression model. And what I'm doing is I'm asking it on the testing data to make some predictions. So here's the model. This is the ground truth. So this is what's in the data that I know, and here's what the model is predicting. So you can see here, right? We're doing pretty good. We're predicting the 0 could correspond to the employee isn't going to leave, 1 could correspond to the employee is going to leave, and we're pretty spot on, right, with our predictions. We also have a probability. This model, the logistic regression model, we're taking a look at what's the probability. that this prediction is actually correct. And in some cases, it's really correct, right? So this is 99% probability that our prediction is correct. Other cases, we're only, 83%? That's still pretty good, but it's not nearly as good as 99%. So in this case, the data is not as clear cut. So maybe the employee is kind of on the fence and we're pretty sure they're going to leave, or rather they're going to stay, but maybe they won't. So we can get that information from the model. And then a typical way, so this is good. I'm only looking at a snapshot of 10 elements though. If I want to get at a view, because there's 16,000 data points here. In order to really look at that, like a typical way to visualize how your model is performing is something called ROC, receiver operator characteristic curves, where it looks at what's your true positive rate versus your false positive rate. The short summary is you want to be up here. A true positive is like, hey, I said the employee was going to leave and they actually left. A false positive is I said the employee was going to leave and they didn't leave. So what you want to look at is you want to make sure you're making correct predictions and not generating false positives. And that's all captured with your true positive and false positive rate. Up here means we're making really good predictions and we're hardly ever wrong. Down here is really bad. That means we're always wrong. And here is where we're just basically saying that the employee is always going to leave. So we're always right, but we're always wrong. So, and then in the middle is like a coin toss. Looking at it another way, we have precision and recall. In general, this looks pretty good. The model accuracy is like 90%. If I come down here, look at the area under the ROC, we're at like 90% of the model of the areas under the ROC. So that's not too bad, especially for a first stab at this. It's not as good as I would like, but it's not the worst model that I've seen. So now at this point, we're going to say, yeah, this is pretty good for a first stab at this. Let's go ahead and save that model. And what I'm doing is I'm including the pipeline run ID. So if I look here, I got a handy run ID that I can use to correlate things. What I'm doing is, whoops, I'm writing out the model name with that run ID so that if something goes wrong with the model, I know what data and what model, rather pipeline run was used to get the data for that model so that I can trace backwards. And if it stops working well, I can, quickly figure out, well, what's going on? Oh, it's the data from this date. Let's take a look. They dropped a whole column. You know what I mean? Or all the column is zeroed out when previously it was all over the place. You can quickly identify, well, what's breaking the model? What's changed? How do we fix this? So I'm right. I only have 2 minutes left here. So we're not going to get to the next steps. The ML ops piece looks something like this. It's pretty. It involves a bunch of different steps. If anybody's interested, we can definitely talk offline. But there's a whole DevOps process. Essentially, it's called ML ops to productionalize this model that we've saved and really get value from that. But what I'm going to do is, in the interest of time, I'm going to pause here and ask, are there any questions?
Feel free to unmute yourself, guys.
Hello.
Hi.
Hello, good evening. Yeah, my name is Yakubu. I'm joining the webinar from Aberdeen in Scotland, in the UK. Thank you very much. Yeah, I was just going to ask a quick question. I see in the last part of the presentation, we're seeing codes. So, and I kind of just assume that when we do stuff in Azure, it's a lot about codeless machine learning, codeless data science. So I was just want to know, did you actually put up all of the codes, or you did everything codeless and it was Azure that brought all of those codes that you were showing us?
No. So I wrote all of the code you saw. There's a lot of codeless solutions in Azure. So if we go back to this picture, if you're looking for codeless, you're going to want to use the Azure Machine Learning Studio, or the Azure Machine Learning Service Designer. In there, you can basically do machine learning without writing code. I have a development background. I like getting into the code, so I did everything with code. And more often than not, when you're doing data science, most of the libraries are available as Python libraries, so you usually have to write code. So I decided to do this with code, but you can do similar things without code using some of these other services. Does that make sense?
Yeah. It makes lots of sense. I just want to be clear on that. Yeah. Thanks a lot.
Yep. Good question. Any other questions?
Hi, this is Shivam from Toronto. Just a quick one, and might not be the right stage or the right place to ask this, but like from a model monitoring perspective, would you export any of the certain monitoring metrics here at this stage here in this part of the code, or is that something that you do after deployment and do you layer it on top, or is it built in as part of the process here?
I think it would kind of it would kind of depend, right? So depending on what you're monitoring, in this case, I would probably be interested in looking. So I would add it at the end here, because the way I would productionalize this, because I'm using a library, I think I can like pickle this up. It's some kind of a Python library that or a PySpark library. If I were to containerize and run this here, I'd be interested in looking at like the accuracy along with the data that came in. Like if I was calling it on demand, maybe log out some of that stuff. But I would add that in as part of like whatever is calling it. So as part, like if I was calling this in batch, I would probably just load the model. And if it was like in a notebook, I would like load the model, take the input data wherever that is, run it, and then log all of the accuracy, right? But for other models, you definitely could build it in, right? As part of it. Like, let me think here. If I had a, so as part of a neural network or something, if I wanted to know what neuron things map to, I could maybe build in some logging there that would say, like here's the different neurons that we map to in training, and then put in some different hooks where I could call into that as like when it actually gets called in at runtime. And then all of those logs and everything, you would feed that into your logging solution. So that would go to like Azure Monitor or Log Analytics or something, and you could analyze those and figure out what's going on.
Okay, that makes sense. Thanks so much.
Answer your question? Yeah, sure.
Yeah. Thank you.
Sorry, a lot of these, there's in a lot of this stuff, there's no like clear-cut answer. Some cases there are, but a lot of times it really depends.
No, absolutely. Yeah, I fully appreciate that. Yeah, really, really helpful presentation overall. Thank you.
Cool. Glad you enjoyed it. Any other questions? All right. Well, I see we're a few minutes over, so I'm gonna stop sharing my screen. Thank you so much for the opportunity to talk with you all today and go through this. I hope this was helpful for everybody. And you have my, so Jean has my email address. So feel free if anybody wants to reach out. If there's anything you want to talk about in more detail, I'd be happy to discuss this. Yeah, was a pleasure talking with everybody today. All right. Is there anything else that we wanted to discuss?
Thank you so much, Daniel, for that one great session. I learned so much from it. Right. One more time, thanks again, and thank you all for your time. Bye.
All right. Thanks, everybody. Look forward to talking soon.